Spiral galaxies. Spiral galaxies are characterized by their distinct spiral-shaped arms that radiate from a central bulge, creating a pinwheel-like structure. These arms are often active star formation regions, where dense clouds of gas and dust collapse to form new stars, making spiral galaxies bright and rich in young stars. At the center of a spiral galaxy lies a dense bulge of older stars, and often a supermassive black hole that influences the galaxy's overall structure and movement. Some spiral galaxies, known as barred spirals, feature a bar-like structure in the center, with the spiral arms extending from the ends of the bar rather than directly from the center. The Milky Way, our own galaxy, is a barred spiral, with its well-defined disk, spiral arms, and central bar, making it a perfect example of this galaxy type. Elliptical galaxies stand out for their simple, smooth shapes. Unlike spiral galaxies, they lack disks, arms, or visible dust. These galaxies are made up mostly of old, red stars, with very little gas or new star formation, making them cosmic graveyards for aging stars. Some of the universe's largest galaxies, like M87, are ellipticals, often found at the heart of galaxy clusters, where they grow by absorbing smaller galaxies. Inside them, stars move in random, chaotic orbits rather than the neat, organized rotation seen in spirals, suggesting a violent history of collisions. Astronomers classify them on a scale from E0, perfectly round, to E7, highly stretched, reflecting their varied shapes. Despite their size, elliptical galaxies seem to have less dark matter than expected, leaving scientists puzzled over how their stars move so fast without it. These galaxies are fascinating relics of cosmic evolution. Lenticular galaxies are a fascinating mix between spiral and elliptical galaxies. They have a flat disk and central bulge like spiral galaxies, but lack the distinctive spiral arms. These galaxies contain mostly old, red stars and very little gas, which means they don't form many new stars. Some have a bar structure through their center, while others don't. They're commonly found in crowded galaxy clusters, where interactions with other galaxies may have removed their gas and spiral features. Astronomers sometimes struggle to classify them because they share characteristics with both spirals and ellipticals. A famous example is the Sombrero Galaxy, which looks like a wide-brimmed hat with its prominent dust ring. These galaxies help us understand how galaxies change over time. Irregular galaxies are the cosmic rebels of the universe. They don't follow the neat shapes of spirals or ellipticals. Instead, they appear as messy, lopsided collections of stars and gas, with no particular structure. What makes them special is that they're packed with gas and dust, which fuels intense star formation, often at much higher rates than more organized galaxies. Most are small dwarf irregulars, but they're actually quite common throughout space. Astronomers sort them into two main types: Irregular galaxies that show some hints of structure, like the Large Magellanic Cloud visible from Earth, and irregular galaxies that look completely chaotic. Many irregular galaxies are either young galaxies still developing their shape, or the aftermath of violent galactic collisions. While they might look disorganized now, some may eventually settle into more structured forms over billions of years. These unpredictable galaxies help scientists understand how all galaxies form and evolve. Peculiar galaxies are the oddballs of space, showing strange shapes and features that set them apart from regular galaxies. Their bizarre appearances, like rings, long tails, or stretched-out wisps of stars, come from violent encounters with other galaxies. When galaxies collide or pass too close, their gravity pulls and twists them into these unusual forms. These cosmic crashes also trigger intense bursts of new star formation, sometimes hundreds of times faster than in normal galaxies. While they look chaotic now, peculiar galaxies are just going through a phase. Over hundreds of millions of years, they'll eventually settle down into more familiar spiral or elliptical shapes. Famous examples include the Antennae galaxies, which are two spiral galaxies crashing together, and the Cartwheel Galaxy with its distinctive ring shape. These galactic oddities help scientists understand how all galaxies grow and change through collisions, including the future merger of our Milky Way with the Andromeda Galaxy. Dwarf galaxies may be small, but they play a big role in our understanding of the universe. These tiny galaxies typically contain just a few billion stars, far fewer than giants like our Milky Way. What makes them particularly interesting is that many are packed with dark matter, making them natural laboratories for studying this mysterious substance. Some of these galaxies are cosmic time capsules, filled with ancient stars that formed over 10 billion years ago, giving us glimpses into the early universe. They come in two main varieties: irregular dwarfs that are still actively forming stars, and faint spheroidal dwarfs that orbit larger galaxies like satellites. Unfortunately, their small size makes them vulnerable. Many get torn apart and absorbed by bigger galaxies over time. In fact, our Milky Way is currently in the process of swallowing several dwarf galaxies. Despite their modest size, some dwarf galaxies like the Large Magellanic Cloud can still produce new stars at impressive rates. Starburst galaxies. Starburst galaxies are cosmic overachievers when it comes to making stars. These special galaxies form new stars at astonishing rates, sometimes hundreds or even thousands each year, compared to our Milky Way's modest one star per year. This incredible star production usually gets kicked off when galaxies collide or pass too close together, squeezing their gas clouds and jump-starting massive star formation. But this boom time doesn't last. After just 10 to 100 million years, a short time for galaxies, they either use up all their star-making gas, or the explosions from all the new stars stop the process. All this rapid star birth creates powerful winds that blast gas outward at speeds over 1,000,000 miles per hour, sometimes completely blowing material out of the galaxy. While all this activity creates dust that blocks visible light, it makes these galaxies shine incredibly bright in infrared light. The famous Cigar Galaxy, M82, is a great example, forming stars 10 times faster than our entire Milky Way. These extreme galaxies help scientists understand how violent cosmic events can temporarily turn galaxies into stellar powerhouses. Active galaxies. Active galaxies are some of the most energetic objects in the universe. What makes them special is their supermassive black hole centers that are actively feeding on surrounding material. As gas and dust fall into these black holes, they release incredible amounts of energy, so much that the galaxy's core can shine brighter than all its stars combined. These galaxies produce enormous jets that blast particles across space at nearly the speed of light, sometimes stretching farther than the galaxy itself. This active phase doesn't last forever, typically just 10 to 100 million years, until the black hole runs out of nearby material to consume. While our Milky Way's central black hole is quiet now, studying these active galaxies helps scientists understand how all galaxies and their black holes evolve. Seyfert galaxies. Seyfert galaxies are a special type of active galaxy with some unique features. At their heart, they have an extremely bright core that can outshine the rest of the galaxy, powered by a supermassive black hole feeding on surrounding gas. This process creates strong radiation across different wavelengths from X-rays to infrared light. There are two main kinds: Type 1 Seyferts, where we can see fast-moving gas near the black hole, and Type 2 Seyferts, where dust blocks our view of the fastest-moving material. Unlike more powerful but distant quasars, Seyfert galaxies are relatively close to us, making them easier to observe and study. The Whirlpool Galaxy, M51, is a famous example with a Seyfert nucleus. These galaxies provide important clues about how black holes influence their host galaxies over time. Quasars. Quasars are the most powerful light sources in the universe. These incredibly bright objects can outshine entire galaxies by thousands of times, even though they're actually quite compact. At their core lies a supermassive black hole that's actively feeding on surrounding gas and stars. As this material gets pulled in, it heats up and glows intensely before disappearing forever. We see quasars as they were billions of years ago because their light takes so long to reach us, giving us a window into the early universe. Many quasars shoot out enormous jets of superheated particles that travel nearly at light speed and stretch across incredible distances. While amazingly powerful, quasars don't last forever. After millions of years, which is short for cosmic timescales, they fade when their black holes run out of nearby material to consume. The famous quasar 3C 273 was the first discovered and remains one of the brightest known examples. Studying quasars helps astronomers understand how galaxies and their central black holes evolve over time. Thanks for watching the video. If I missed any galaxies, please let me know in the comments, and consider liking and subscribing for more space-related content.